Today we'll be talking about unit conversions. But what are unit conversions? Unit conversions are when you have the units of something, but you want to convert them to different units. It's pretty self-explanatory. So think going from inches to miles, cups to gallons, different things like that. So there's two different types that we'll be covering today. One is normal, and the other is using chemical equations. So chem equations. So they use the same principles, but when you think about them outside of the context of like in different contexts, right? It's easier in my mind to go from inches to feet, feet to miles, than to go from grams to moles, moles to grams, or vice versa, or moles to molecules. So let's say, for example, I give you 57,846 inches. And I tell you, I want you to convert that to miles. Well, what do I know? I don't know how many inches are in miles, but I do know how many feet are in an inch. And so there are two things that I try to do first. Half of the battle is trying to figure out the next step in this. So if I know what I'm starting with, and I can figure out the next step of going from inches to feet, um, that's a step in the right direction. And then feet to miles, that's also another step in the right direction. Um, the other thing is I always try to cancel out what's at the top left. So here, this is the only thing we have. It's in the top left. And when I say thing, I mean units, right? So I'm going to try to cancel out these units. Most people, when they're solving this, they would just say, okay, if I'm trying to go to miles, I divide by 12 and divide by 5280. But the problem with that is sometimes you forget what the units are, or you write down the wrong units, and then you lose points on exams. So what I'm going to do is I'm going to say 57,846 inches, and instead of dividing by 12 or 12 inches, I'm going to multiply by 1 foot over 12 inches. And the reason I do that is because this now cancels, and it tells me explicitly that I have this many feet. So if I multiply this through, it tells me right here how many feet I have. Now I'm going to try to go from feet to miles. Well, I know that there are 52,000 or 55,280 feet in 1 mile. And so I'm going to put 5280 feet on the bottom and then 1 mile on the top. And then these are going to cancel out. And I'm left with the unit of miles, but I'm using the right conversion. So this is the same thing as this divided by 12 divided by 5280, but it gives us, and it will give your teacher the way that you've went through this. So you can show your work, your teacher can see explicitly what you did, and you won't get the units wrong if you do it this way. So if you multiply that out, if you're following along with me, this is going to be 0.913 about miles, and you're good. Now, when it comes to unit conversions using chemical equations, it's a little bit more difficult. Um, and the reason it's difficult is because these are a little bit more conceptual ideas. So think like grams and moles are difficult to think about in your head. Um, and then going from moles to molecules, even that's pretty difficult. So what I do is I like to think about chemical equations first, like a recipe. So say for example, we have 2 cups of flour. So 2 cups of flour. I'm just going to abbreviate to FL plus 1 egg gives us 1 bread or 1 loaf of bread. Okay. Well, if you have 2 cups of flour and 1 egg, and it makes 1 bread, you know that 2 cups or 1 bread is made from 2 cups of flour, right? Or 1 bread is made from 1 egg. And so this is, I'm specifically showing the ratio of what the final product is compared to the ingredients, or in other words, the reactants. So now applying that to a chemical equation, let's look at this. Let's say, for example, that I have this chemical equation. I want to start on a new piece of paper. Let's say, for example, I have this chemical equation. Let's say I have 2H2 plus O2 yields 2H2O. So this gives me the ratios that I need to balance this equation, right? So I have, first off, 4 hydrogen on this side, 4 hydrogen on this side, 2 oxygen on this side, 2 oxygen on this side. So the equation's already balanced. Now, let's say, for example, I give you 7 grams of O2. Well, how would I find the grams of H2O? If I give you 7 grams of O2, could I find the grams of H2O that are made in this reaction? The answer is yes. So you can't compare grams of one substance to grams of another, because the number of molecules in that mass could be different for both substances. So what you have to do first is you can compare moles. So how would I convert this to moles? Well, I know O2 has 31.998 grams per mole. And so if I wrote 31.998 grams on the top and 1 mole on the bottom, you'd get grams squared over moles. Or in other words, you get the wrong units. You need to divide by 31.998 or multiply by 1 mole O2 over 31.998 grams of O2. Because remember, this is going to cancel. These units are going to cancel. And then you're left with the right units that you want next. Now, this is where the tricky part comes in. I need to figure out how many moles of H2O I can make for every mole of oxygen. So I know that I can make 2 H2O molecules or 2 H2O moles, either way. I'm going to abbreviate to MOL just to save some space here. So 2 moles of H2O per 1 mole O2. Well, that cancels out as well. And so now I've gone from grams of reactant to moles of product, but I want to end up with grams of reactant. And so using the molar mass, I need to get rid of these mole of O2 or of H2O. So 1 mole H2O is going to go on the bottom, and then 18.015 grams of H2O is going to go on the top. So moles of H2O cancel out, and I'm left in the end with grams of H2O. And that's going to give me 7.88 grams H2O. So this is our answer. Now, if we went through the same thing, but say we had 7 grams of H2 instead of 7 grams of H2O. Well, you would use the different molar mass for H2. But this step, you'd have 2 moles of H2 over 2 moles of H2O. And how do we figure that out? You look at the coefficients. So if there's no coefficient, we assume 1. So that's what we did here. But if there is a coefficient, We do this coefficient over this coefficient, gives us the molar ratio, which helps us determine how many moles of H2O we're going to make per how many moles of reactant we have. I hope that was helpful. If you have any questions, comment down below, and please subscribe if you would like some more content like this.